Okay, so this time we will discuss what is rational expressions, rational equations, rational inequalities, and rational functions. Okay, so let us first have a short review on what is a polynomial or what are polynomials. So polynomial comes from poly, meaning many, and nomial in this case meaning term. So it says many terms. So a polynomial also can have constants, variables, and exponents, but never division by a variable. So these are examples of polynomials. We have 3x. So the variable there is x, and the numerical coefficient is 3. We have x minus 2. The variable is x, and the constant is negative 2. Then we have negative 6y squared minus 7 over 9x. We have two variables, the y and x. The exponent of y is 2, and the exponent of x is 1. Another examples of polynomials, we have 3xyz plus 3xy squared z minus 0.1xz minus 200y plus 0.5. So there are 5 terms on these polynomials. Another example is 512 v5 plus 99 w5. Then the last example is 5. Take note, 5 is a polynomial. It is a constant. No variable exists and no exponents for the variable. So these are not polynomials. We have 3xy raised to the power of negative 2. This is not a polynomial simply because the exponent of the variable is negative 2. Take notes, in polynomials, the exponents would be a whole number. It could be 0, 1, 2, 3. Not fractions, not negative integers, not negative numbers. Okay? It should be a positive or a whole number or a positive numbers. Positive integers. So another example which is a not polynomial is 2 over x plus 2 because dividing by a variable is not allowed. So take note, in a polynomial, there should have no variable in the denominator. 1 over x is not a polynomial simply because the variable x is in the denominator. Then square root of x is not a polynomial because the exponent is 1/2. So again, the exponent of a polynomial should be a whole number, 0, 1, 2, 3, and so on and so forth. Let's proceed to rational expressions. Okay, so a rational expression is an expression that is the ratio of two polynomials. So it is good that we have reviewed on what is polynomial so that we can identify what is irrational expressions, because rational expressions is made of two polynomials. Just like, for example, we have the x squared plus 5 over x plus 2. The numerator is x squared plus 5. The denominator is x plus 2. So in that case, the two polynomials are one in the numerator and the other one is in the denominator. That is a rational expression. So we have these examples of rational expression. We have x cubed plus 2x minus 1 over 6x squared. So that is a rational expression. In the numerator, it is a polynomial. Then in the denominator, it is also a polynomial. Another example is 2x plus 9 over x raised to the power of 4 minus x squared. So that is a polynomial. Take note, as what you have observed, on the given example, the exponents of our variables are all positive. Okay? So therefore, that is a polynomial. Here we have 2x squared plus 3. So in this case, why is it this is a rational expression? Simply because the denominator here is 1. 1. So 2x squared plus 3 divided by 1, that is equal to 2x squared plus 3. So it is understood that the denominator of these rational expression is 1. The fourth example is 1 over 2 minus x squared. So that is also a rational expression. On the other hand, these are not rational expressions. We have 2 minus square root of x over 4 minus x. What makes this not a rational expression? Simply because of the numerator. 2 minus square root of x. Square root of x means that is equal to or the same as x, wherein the exponent is 1/2. Another example is 1 minus x over 1 plus 1 over x. It is not also a polynomial simply because the denominator of the polynomial has a divisor or has a denominator which is a variable. So meaning 1 plus 1 over x is not a polynomial. So let's proceed in rational equations. So a rational equation is an equation containing at least one rational expression. So rational expressions typically contain a variable in the denominator. So for example, we have these examples. 5 over x minus 1/3 equals 1 over x. So there is a variable in the denominator of our rational expressions. Another is x over x plus 2 over x squared plus 5x plus 6 equals 5 over x plus 3. Then another example is 2 minus 1 over x times x plus 1 equals 3 over x plus 1. Fourth example is we have x over x plus 12 equals 2 over x. So as what you have observed on the given examples, there is a variable in the denominator. Another is 1 over x plus x over 2x plus 1 equals 0. Then the last example is 3x over x squared minus 4 minus 2 over x plus 2 equals 1 over x plus 2. So another hint here that it is a rational equation is that there is an equal sign. There is an equal sign. Okay? So in rational expression, on rational expression alone, there is no equal sign. There is no equal symbol. So in rational equations, there exists an equal symbol, an equal sign symbol, at the same time, irrational expressions. So this time we will proceed to rational inequalities. Irrational inequality is an inequality that contains irrational expression. So if we talk about inequality, there are symbols which is greater than, less than, greater than or equal to, or less than or equal to. So examples are, first, we have x minus 1 over x plus 3 is greater than or equal to 0. So there is a symbol of an inequality sign. We have the greater than or equal. Another one is negative 7 over x plus 5 less than or equal to negative 8 over x plus 6. So it uses the inequality symbol which is less than or equal to. Another example is x squared minus 5x minus 6 over 3x squared less than 0. Then we have 3x plus 1 over x minus 1 greater than 2. Another example is we have x plus 7 times x minus 3 over x minus 5 raised to the power of 2, which is greater than 0. Then we have the last example, x plus 5 over x minus 4 is less than or equal to 0. So those are rational inequalities. Next is we have the rational functions. Rational function is any function of one variable. X is called a rational function. If and only if it can be written in the form f of x that is equal to p of x over q of x, where p and q are polynomials of x and q of x should not be equal to 0. For example, we have f of x that is equal to x squared minus 4 over x squared minus 4x. So our function function of x is equal to x squared minus 4 over x squared minus 4x. So for the numerator, we have x squared minus 4 that is a polynomial, then x squared minus 4x for the denominator, which is our q of x. Second example is f of x that is equal to 9 over x squared minus 9. So our numerator, our p of x is 9, while our denominator is x squared minus 9. So third example is f of x that is equal to negative 4 over x minus 2. Fourth example is we have f of x that is equal to 3x plus 6 over x minus 1. So same thing, our numerator is a polynomial which is 3x plus 6, while the denominator is over x minus 1. So we have that polynomial x minus 1. Then the last example is we have g of x that is equal to x raised to the power of 3 minus 2x over 2x squared minus 10. So the numerator is x cubed minus 2x over 2x squared minus 10. Okay, so the denominator is 2x squared minus 10. So the denominator at the same time the numerator are polynomials. Okay, so these are examples of rational functions. It's either g of x, f of x, h of x. Just make it sure that the numerator at the same time the denominator are polynomials. For the last example, f of x that is equal to 2x plus 1 over 2x plus 4. The same thing. So let us have this exercises. We have this activity. Determine whether the given is a rational function, rational equation, rational inequality, or none of these. For number 1, 1 plus x over x minus 2 equals 4. So, is it a function? Is it a rational function, rational equation, or rational inequality, or none of the three? So for number 1, that is irrational. That is irrational equation. In number 2, that is a rational inequality. So it is easy for us to determine if it is irrational inequality simply because it uses the inequality symbol, which is greater than, less than, greater than or equal to, or less than or equal to. So for number 2, it uses greater than, so therefore it is irrational inequality. Number 3, f of x that is equal to x cubed minus 2x over 2 times the quantity of x squared minus 5. So in this case, this is a rational function, f of x, g of x, or y. So it is easy for us to determine if it is a rational or not, or rational function or rational equation. Number 4, we have x squared, negative x squared plus x minus 8 over x minus 3 times the quantity of x plus 5 equals x over x minus 3. So, are the numerator at the same time the denominator is polynomial? Check. So, it uses an equal sign. So, therefore, it is a rational equation. Okay? So, that's it for today. I just hope that you have learned something from my discussion. Thank you, everyone.